Hello everyone, my name is Matheus Rodrigues and today I will present the work entitled Gonanoparticles Treatment Improved the Cognitive and Neurochemical Alterations Related to Hypercholesterolemia Experimental Findings. The hypercholesterolemia is a well-known risk factor to cardiovascular disease development, mainly that related to atherosclerosis disease. But in recent years, the hypercholesterolemia is also related to cognitive deficits and neurodegenerative disease occurrence, such as the Alzheimer's disease. Mechanisms such as the blood-brain barrier dysfunction and consistent neuroinflammation seems to be the connective factors between hypercholesterolemia and brain dysfunctions. In this sense, the use of anti-inflammatory compounds, such as the gold nanoparticles, seems to be an important therapeutic strategy to mitigate the cognitive deficits related to hypercholesterolemia. Here, in order to better investigate the therapeutic effect of gold nanoparticles in the context of hypercholesterolemia, we offered to male Swiss mice with 3 months of age a high cholesterol diet during 8 weeks. During the same time, the animals received by oral gavage the gold nanoparticles. After that, the animals were submitted to behavior tests, and the brain structures and the plasma were collected to the further performance of biochemical analysis. As we can see in the figure 1, the offer of a high cholesterol diet significantly increased the plasma cholesterol levels of the animals, which was not affected by the gold nanoparticles treatment. In addition to that, we also observed that hypercholesterolemic mice ingested less food, but ingested a higher calorie intake and exhibit a higher body mass when compared to the control group. All these parameters were not affected by the gold nanoparticle treatment. Regarding the behavior tests, we observed that hypercholesterolemic mice exhibit higher cognitive deficits at the recognition memory test and exhibit a higher depressive-like behavior and a higher cataleptic posture when compared to the control group. All these parameters are mitigated by the gold nanoparticles treatment. Finally, we also observed that hypercholesterolemia is related to a higher blood-brain barrier dysfunction at hippocampus and the olfactory bulb, which was mitigated by the gold nanoparticles too. Taken together, our results indicated that the gold nanoparticles treatment potentially mitigated the cognitive and neurochemical alterations related to hypercholesterolemia. Thank you all for the attention, and it was a pleasure.